Good morning. Thanks everyone for being here. Smaller group than yesterday. Profiling is a little bit more of an advanced topic, so this will hopefully build on a little bit of what you've learned the first day. How's everybody doing? Enjoying the conference? Learning lots? And something similar to what has been said about the other presentations. This is going to be a little bit of rapid fire. We can't learn profiling like hands-on in 40 minutes, but you'll get a sense of what to do, and I'll give you a good example of how we're going to do it, so you get an idea. So I'm Viet Nguyen. For those who weren't here yesterday, I'm an internist, pediatrician, been working in interoperability around terminology, and a little bit on CDA, and then working with FHIR for the past about 5 years. I was in industry supporting government contracts with VA and CDC and CMS, and I'm a consultant. Also work for the Health Services Platform Consortium as a volunteer CMO to help promote interoperability. And I am the technical director for the HL7 DaVinci project, which is a group of payer providers and EHR vendors that are working under the auspices of HL7, looking at value-based care projects and looking at ways to utilize HL7 FHIR to support that. And I'll be giving a presentation, 2 of them, tomorrow on that topic. So I've been a FHIR clinical champion and an educator, helping to educate clinicians about FHIR and so that get them to use it and be able to support their development teams. How many clinicians do we have in the room? All right, how many kind of analysts type folks? And how many developers? All right, so I don't get too far into the weeds in the development part because this is kind of higher level for clinicians. So the topic is around profiling. And so why do we need profiles? We need profiles because we have lots of different contexts in healthcare, and the FHIR resources as they're designed are kind of high-level resources and a pretty high level of abstraction. And when you get to the point where you're actually building an application, developing use cases, you realize that that level of flexibility is too much flexibility, and you want to constrain the resources down so that you can be confident about the information you need to send, and the person or the organization and the system that receives the data can be more confident about what they're going to receive. And in order to do that, we have to be able to take these resources and start to constrain them down based on our use case. So the wonderful thing about FHIR, and the thing I love the most, is that the computable nature of it. I think hopefully don't have to sell you on that value, and the fact that now we can create profiles that we can define as we create them, and they can be processed by an application or a server, and we can validate based on how we define that profile. So I think there's a lot of important value to that. So profiles in FHIR kind of fit the same purpose as they do in CDA templates and implementation guides. Is to make sure that we're applying a standard uniformly. We have implementation. So profiling is one part of developing implementation guides, and in an implementation guide, if you have the Argonaut implementation guide and now US Core, it defines not only these resource profiling, which is what I'm going to focus on today, but also the context of how you would use these resources and the narrative information. And one thing that we're making an effort is actually taking best practices around how to create implementation guides now and developing education around that. Because in my mind, the progression of knowledge and education around understanding FHIR from a clinician's point of view is start with, do you understand FHIR, what those resources are? Can you create resources around them? Can you then connect resources together like we did yesterday with the ClinFHIR tool? Can you then profile? And this is where a lot of clinicians are, and clinicians on FHIR, learning how to constrain these resources. And then ultimately, can you then support a group that's doing use cases and create an implementation guide around a context? So we have implementation guides for quality measures. I'm working on these ones for DaVinci around value-based care use cases. But they're not mandatory, but they do help a lot in terms of making things more interoperable. So this is a resource. And as you can see, this is the kind of the UML view of the resource. And if you look on the website on any given resource, you'll have JSON view and these different views. But when we look at a resource, we can then, we have a lot of optionality in the resource. So we have identifier here for this patient has 0 to many. We have almost everything actually in patient is 0 to many, which means it's really flexible and you can create a valid resource, but it may contain no useful information. And so what we do then is to constrain it down. You might say that you want an identifier that's a national patient identifier. For one of our use cases, we say we want to make sure that in our practitioner resource we have the NPI, because the use case is that payers always need the NPI of the provider. You can limit names or constrain names. You might say that a marital status comes from a given value set. And in the case of the US core, when they looked at patient and the Argonaut folks that became US core. So just for clarity, you guys know that the Argonaut was a group that was formed using DSTU2 to create a set of profiles to support meaningful use. And those profiles were then adopted in STU3 of FHIR, and now they're called the US core because they're overseen by the US realm work group. And ultimately they'll be in R4, they'll be profiled in R4 after R4 is balloted. So when you hear US core, you think Argonaut, they're nearly synonymous. But when we looked at patient in Argonaut, we realized that in the US, we feel it's important to carry information around race and ethnicity, but FHIR doesn't support that. So when they took that patient profile, they did what's called extensions. They added a data element for race and ethnicity, and they also defined the value set for race and ethnicity. And that's part of what you'd expect in a US core patient profile, an instance of it. So a profile is just a resource, like any other resource in FHIR. And when you create it and you have your own FHIR server or you have a registry, you can post that to the registry so that it's retrievable by others, maybe reusable by others, and it's computable. And in yesterday's discussion, when I showed you ClinFHIR, we had the 3 servers in ClinFHIR. You have the data server, the conformance server, and the terminology server. Those profiles sit in the in the conformance server, which may be the same server if you have all that functionality, but just where the system needs to know where to look for those profiles. And so, so when we use profiles, we can use them in two different situations. One, you can use them to create your user interface, and when you input the data in the user interface, you can validate that data conforms to that profile. So yesterday when I showed you that I was creating a resource and I clicked validate, what the application, the ClinFHIR client did was go out, find that patient resource on the conformance server, came back with the definition, and then checked my JSON or my resource, and to make sure that it had all the elements. So had I put in a loin code where it should have been a SNOMED code, it would have errored out. So that is, I call it the data creation part, and then I post it. You can validate, the server who receives the data can validate that it's correct. And then if I query on data and I pull it back, I can use that profile to make sure that resource is conformant as well. So there's lots of opportunities to make sure that data is consistent. So we have lots of conformance resources within FHIR to do profiling. Within terminology, we have code systems. We can create value sets within code systems. We can name and identify the source of truth for that code system, and we can have maps between code systems. We have content conformance around the data elements and the structure, and when we can have conformance around the behavior, both computable conformance as well as what we write into an implementation guide around you must support if you have data that isn't necessarily computable, but at least it gives you the best practice around doing the profiling. And then we test the conformance by developing an implementation guide that has the profiles already in them that you can ingest computably, and then be able to do validation against them. And then we have a paradigm, and we have vendors supporting the paradigm around creating test scripts. So you can create resources and do a test script to make sure that the resources were created correctly, they're posted correctly, and are retrieved correctly. And so conformance, so all resources are really structured definitions where you define data elements, nesting, the value sets, the data types. And so that's what makes them all computable. So when we say profiles on a resource, you could be profiled on a base resource, or you can actually create a structured definition. And so they're nearly synonymous. So when you hear me profiled on a patient, I would be profiling on the structured definition of the patient. So let's see. So once you create that structured definition, you define it. In the implementation guide, there's consistency within FHIR. You'll notice the pages all kind of look the same. You can then publish and be able to have the user look at the human readable version, and you'll have the differentials, and you can look at it in UML and XML. And that's all part of the publishing process, which I won't get into today because it's more complex. Let's keep going. So at each layer, you define the conformance at the resource layer, at the data element layer, and then at the value set layer. So in profiling, early on, I used to make a distinction between a profile where you're just constraining existing elements and making a distinction between adding extensions and calling those extensions, but in reality, I think everybody calls profiling just profiling. And part of profiling is also creating extensions. So when you do a gap analysis, you may see that there are data elements in your base resource that are missing that you really need, just like our race ethnicity example. And so what you do is you create an extension. And the beauty of FHIR is that you define those extensions in a computable way, and you define not only the data element, but also the data type. So whether you're adding a new human name, you're adding a codable concept, and if you add a codable concept, you define the value set or the code system that codable concept comes in. So that's what makes it computable, and it can be checked and validated. So this notion of the must support and shall support is further constraining the profile, and a context where you might use it is, say you want to send some additional identifiers with a patient resource, and the patient resource supports a whole number of identifiers. So if you have that information, the US core patient as an example, if you know the birth date, you must support that birth date and send it. But if you don't know it, you're not going to fail the technical conformance. It's just you don't actually conform with the implementation guide. So that's a useful concept to know, because as you're building stuff, you'll talk to the vendors and say, well, we don't actually capture this information. But the group together says, yeah, but it's important information. Maybe you capture it in your next iteration of your software, so we make it as a must support. You can extend names of elements. That's fairly straightforward. You can extend extensions. So you can make nested extensions like we do in the patient resource in US Core. And you can make the constraints that requiring things that within the resource itself, the referring to something within that resource, or you can also constrain what the resource will refer to out. And in the example I show you, we're going to do that. One of the main things that we do in profiling is that we constrain cardinality. Like in the patient resource, 0 to many is the cardinality on almost every element. So when you're working through your use case and with your group, you will say, do we have to have this? If we have to have it, then we make it 1-to-1. If we have to have it and there can be more things, you make it 1-to-many. I'm using terms that I'm sure may be simplistic to you guys, but we often have clinicians in the room that don't always use all these kind of modeling terms. But you can also say that we don't use it at all. And the challenge and the tension when you're working in your own teams and with other groups is deciding what to make required, what not to make required, and constraining enough that you have confidence in what you're sharing and have flexibility enough so that the vendors can actually implement it. And it's, people use the term healthy tension, and I think it is a healthy tension because that's why the challenges of working in the standards process, and it's just trying to meet real-world implementation requirements with the ideal. You can limit value domains, so we can say that something is a datetime or a Boolean. You could also have these optionality where you have the X, where you'll have a list of possible data types, and you could say you have to pick one of these data types. So for deceased in one of the resources, it could be one data type might be date time if you actually know when the patient was deceased, or it might just be a date, or it might be a Boolean so that you know that the patient is deceased. So that gives some optionality. And then you put any amount of kind of narrative in there to help with the implementers to implement. So we have different kinds of binding. You have fixed binding, so you have to use you have to use the value sets in the binding that's defined. You can have incomplete binding, where you can add additional if you want. You can create examples. There are value sets. If you use an existing value set, like if you're going to use gender, we use the HL7 administrative gender. Great. But if you, for some things that we don't know what that value set is going to be, you might get some examples, and that's an opportunity for you to define for your organization, your use case, other code sets that either you create or you adopt from another code system. And within the coded concept, it's important to understand the difference between a code system and a value set. So a code system, think of them as a dictionary. So SNOMED is a code system, LOINC is a code system, and a value set is some subset of that information within the code system. And in FHIR, you can define the value set piecemeal, like I'll pick this code or this code and this code and make a fixed list, or you can also define a definition to it. So for condition, the condition code is give me all the children of the code of clinical finding, I think. So you can actually build out a list of valid codes, and that list, because SNOMED gets updated every 6 months, can change over time, but that definition may not change over time. And so it's useful when you do it like that, because it gives you flexibility, but if in the sending system, but the receiving system, you have to be in sync to know which code system you're using and which set. So when you send codes, within the definition is also the code system and the OID. So that's important to know. But the other way you can do it is you can use a mix of codes. So it's possible, and sometimes you want to use a SNOMED and a LOINC. And so you have to define the valid set. So you might pull it from 2 different code systems. So we talked about that. This is more about what we return. So there are opportunities to do references, define references as your data elements. So an important thing around profiling is you'll see when you look at the spec that there are referenced resources. So in observation, it has a reference to a subject. That element's called subject, and the definition defines patient as the resource that it references. So you can define a number of resources that are fixed, like say reference, practitioner, and related person, or you can reference any, and you can do a reference to any, which means that when you create the resource, you can put in any valid FHIR resource in, and it'll still be conformant. Or you can create a bundle. Bundle is a resource where you can bundle a bunch of resources and define that bundle. So you don't need profiles to do FHIR, and initially when you're just learning about FHIR, I recommend actually not trying to do profiles and just work with it to understand how the resources work and relate to one another. You can define documents and messages with it, define the extensions, and you set the bar when you define these implementation guides that you expect the people who use them to meet so that they can communicate effectively. So profiles, you can use multiple profiles simultaneously, and each might have a different code set, and the idea is that in your implementation guide, you might pull profiles from like US Core, and you're also creating your own. And so you might have multiple profiles in your use cases. You can declare profiles. This is more a little more technical, but a server can declare what profiles they support through their conformance statements, and like you saw in the demo yesterday with ClinFHIR, you can pull profiles into ClinFHIR in order to create a resource. And when you define that I want to create a resource based on this profile, ClinFHIR actually reads the profile definition, the structure definition, and when you go to add an element, David Hay has created the user interface, the boxes to match what you would expect to see. So that's very useful. So there are different tools to use in creating profiles. The first one, the one that's the HL7 method, is Forge. It's a desktop application that you can download for free, and you can import profiles, create profiles. It'll create the structure definition, and it's tied into SimpliFHIR, which FHIRly, the hosts, it's their application, and they'll host these profiles. And so you can create these profiles here, and then for SimpliFHIR, and I can show you, we have a little bit of time, how these profiles look in SimpliFHIR. Trifolia is an open source tool from Lantana that allows you to also create profiles. One nice thing about this application, and we're using it in DaVinci because it's open source, is that it's tied to VSAC, the Value Set Authority Center. Yeah? Acronyms. And they're kind of the gold standard of value sets. The challenge that they're well aware of is that you need an individual license to access that because of CPT and our national contract with SNOMED International. I think they changed their name from IHT SDO. And so what Trifolia does is that they get your password and they hash it, and they pass that to VSAC so that you can use the VSAC code sets. The value is, if you know you're going to use the HL7 administrative gender, you don't have to rebuild that code set. You just do the reference to that code set in your profile. So that's very helpful. As I mentioned, a server can define and tell you, based on its conformance statement, what profiles and resources it supports, which is very helpful. And you can query on the capability statement of that. We'll go fast. So this is SimpliFHIR. And within SimpliFHIR, you can see resources and you can validate resources, which is really helpful. They have the ability to do, I have just a one-person account, one project, but you can have organization accounts and do multiple projects and collaborate. And then HL7 actually has a contract with SimpliFHIR to host implementation guides and profiles. And if you're a member of the FHIR Foundation, who's a member of FHIR Foundation? I have a sticker for you. Awesome. Become a member of the FHIR Foundation. Is really going to help support the implementation community, but they also host implementation guides as well. So I did a whole bunch of quick screenshots last night because Priya gave me a good use case because I could do a kind of a nonsensical use case, but I figured I want to do something useful. So this is ClinFHIR.com for those who have not used it or were not here yesterday. Who was not here yesterday? Okay, so a good number of you. So go to ClinFHIR.com. There's some tutorials. The tutorial from yesterday that I gave will be available to you, and you can almost walk through it using the examples that I gave. But one of the modules here is called the logical modeler. And so I'm going to use the logical modeler, and within the logical modeler, I'm going to create a new logical model, and I called it clinical oncology, condition oncology. Not all the screenshots kind of work together because I missed taking some screenshots, but hopefully it'll be logical. I named the model. I gave it a title. I gave it example profile for DevDays. I put my name in, and I said, I want to do a profile on the condition resource and copy all the elements of an existing condition resource. And the use case came from the idea that we have an oncology patient who comes. They might have a condition, and we want to use some clinical decision support or something else but we want to be able to send that condition, and saying that the patient has adenocarcinoma of the lung just isn't enough in order to give enough information for a clinical decision support system to help. So we want to actually also provide them the staging, the TM and the tumor metastases and nodes staging. And so we thought, like, how are you going to do that? It's always a good question. Like, how? So the first thing I do when I look at profiling is, has anyone else tried to tackle this question and figure out if anyone's tried to tackle it? Because I'm happy to adopt other people's profiles if they make sense for me. And that's why I often will start with US core for some of the base profiles. So I create the logical model, and it brings up this screen. And you have some different views of the model. And you'll see once I click on an element that the element details be on the right. So these are all the base elements. And so if I was working at home or with a group, I'd have another screen that had the condition resource from the specification, so I could read to make sure I'm understanding each of these elements. And so what you would do is you would click on an element, and you could then decide, you would know a little bit about it, the description from the original specification. Right now you have the cardinality, and you know that it's an identifier data type, and then you can either edit the element, add the element, remove it, or copy it. And so what I did was I wanted to say you have to have at least one identifier instead of saying 0 to many. So I went to the edit mode, I left everything the same and just clicked on 1 to many, and then I saved it. And then I went to clinical status and decided I wanted that, you would have to have some clinical status. And then I did that for verification, where I left it the same, because you may not want to verify. And one important thing around FHIR resources, as you're doing this modeling, is don't think of these resources, especially condition, as only a point in time. Because the resource, just like the patient's condition, evolves over time. So you might start with a preliminary diagnosis, if that's one of the categories, and then go to a final diagnosis. And you would be able to track the change of that resource over time by its history. But you also have to know that when the base queries always returns the most recent version of a resource. So then I looked here at assessment. So if you look at the base resource of this, you have assessment, or actually stage. You can only have 0 to 1 stage in this. So I can't expand that constraint. I could limit it to 0 to 0 or 1 to 1, but I can't expand it. But the idea here is can we use stage to do staging of the TMN? And what you can do is, if you look at the assessment, is that it's 0 to many. So I can have 0 to many, and the data type are resources, and they define 3 resources that you could use in the assessment: clinical impression, I think diagnostic report, and more importantly for us, observation. So they've already constrained it, and I'm going to say that you can continue the clinical impression. I didn't want to limit that. And I thought to myself, okay, observation is one. Has anyone done any stuff around staging using observation and LOINC codes? And so I went to the LOINC website, loinc.org, which I encourage folks to do, and I just typed in TNM and found these 6, they turn out to be panels, LOINC panels as opposed to specific LOINC tests. And here we decided for our use case, the discussion we had is, how do I represent the patient's condition with their staging at the point just after all the diagnostic workup has been done and before treatment is implemented? And it turns out there is a nice stage right here, TNM, clinical staging before treatment panel cancer. And looking at that, I have a set of LOINC tests that are part of this panel. And the observation resource actually allows you to support either one specific LOINC test or a panel. So if you look at the US core, there's a panel for vital signs. It's a good example of showing how you can have multiple tests or values in a panel. So this looked like a really good panel, and the way I would know, oh, I didn't do it. Let me switch over. Let me see if we can do this. Because we asked the question, well, I have a LOINC code for the test, but will it provide me the answers I need? Because in each of these staging, oh, that's no good. Sorry, just slow network. Everybody's on the network. Yeah, I'm competing with everything else. But if I was able to show you, and I meant to do it, towards the bottom, each of these codes allows you to have any number of those stages, 1A, 3, and all those. So it would support your stage thing. And I think in combination within that condition resource, if you have the diagnosis, the condition code, there's a location for body site, and the stage, you probably would be able to provide enough information to your receiving system for them to process it. But this was an example where I would have, I added a specific element that says you have to have this resource. And I didn't define it for this use case, but I would have defined an observation profile to support this staging observation. So I can tell this that you have to have a reference to that other profile. So I've now nested profiles. And so the other thing I did just for fun was that I did a little extension. I added a protocol. I added another element. I could have defined it as a codable concept, a string, any of the valid data types. I put string because let's say I want to track what protocol the patient was on for this particular condition. Maybe it's useful, maybe it's not. And that's part of your use case evaluation and your analysis. And so once that was done, I can look and see how this definition of this profile would look as a table or as the JSON. And what I can then do is go to export and then generate this profile. So I generate the profile, it runs through and tells me what elements it generated as part of the profile. It gave me a response, so it was saved successfully, that it created a structured definition. And so, as I mentioned yesterday, let's validate it, make sure it works. So I had assigned this, my environment to the Happy server. So I went to the Happy server and I created a query of structured definition, and I put in clinical condition oncology. I had saved it twice. So I have two profiles, but they're not the same because they actually have two different identifiers. And I was able to find it, and I have the JSON. And so what I did here around the TNM staging, I have the information that is the target profile. So had I created another profile on that observation, that's what I would have pointed to. The important thing is that conformance server, ultimately, when you use it, you have to have all these profiles in the same place or be able to provide them the URL to find the definition, the structured definition. But this is the great thing about FHIR. It's all connected. Do I seem overly enthusiastic about the computability nature of it? Because I'm real. It's so cool because it's not, you don't have to do the cognitive test to say that, would this work in real life? And I go, no, let's do it and see if it works in real life. So that's why I'm enthusiastic about it. So then, within ClinFHIR, I go to my clinical scenario, and I set up to my patient, and that server, that Happy server, had a bunch of these logical models, these structured definitions, and I can do, there was a button here to click Add Resource, and instead of adding my base resource or looking for a profile on one of the other ones, David had it so it'll pull up all the logical models. And because because I already posted to the Happy server, this was already there. So I clicked it, click Add, and there it is. And now I can create the resource. The challenge now is I can create it as examples, but it won't validate. He's working on that. But at least you can go from looking at what your model might look like, creating kind of a first pass level approximation, and then creating some JSON to see what it looked like. Then you can bring it back to your group and say, does this make sense or does this not make sense? And I think that there's a lot of value to that because we were having a conversation yesterday, well, we could do it this way or we could do it this way, and go, why don't we do it both ways and see how it works? And see if it makes sense. And this is where actually making it real and taking it from a speculative conversation to real code has a lot of value. So that was profiling fast and dirty, but there's a whole process. Actually, let's take a moment and actually use SimplFHIR, if I can get on. And see if I can log in. So you can see what these profiles look like. Still network. Let me see if I can. It's helpful to see what other people have done because it can be a little abstract. So I could do a search of profiles. Okay, and I can see that there are all these. I can narrow my query. But let's just look at the U.S. for care plan, and I can look and see what that resource looks like. So it tells me all these the required elements. Gives me some details. It can tell me the status of it. If you have mappings to V2 and the RIM, you put that in. And some of these are beneficial when you're creating the profile, but not always required. The other beneficial aspect, you have this canonical URL for when you use it. And then as you're creating the profile, you can actually, it will host that profile on their server, and you can use that identifier and the URL in ClinFHIR. I've done that too, where I give it the address for the logical model, and it's here. So it's all this way where all these FHIR servers are kind of communicating with each other in a uniform way. So here's a structured definition for this resource. Yeah, it's just a little slow. But I encourage folks to work with your team. Get on chat.phir.org. Lots of conversations going on there, and seeing if you have a question, search through there first to see if anyone else has asked that question. And if no one has, pose the question on one of the streams. It's really a great community where folks really want to help each other answer the questions, because creating the spec is one part of learning how to use FHIR, but actually doing it, it really does benefit from the help of the community a lot of times. So you become proficient and you become the help to the community. So thank you.
I actually have two questions.
Sure.
You did show an example of eliminating an element. Did you simply change its multiplicity from X to 0?
Yes, you can do 0 to 0. Okay. Yeah.
And the second one was, what if I develop my profile in Trifolia? Is there a way to then access that profile in FHIR?
Yes. So if you took that profile in the structured definition, you could, if you had your own server, you could post it to your server. If you had that structured definition, you did, like we talked about HSBC and your own server in HS, you post it to there. You could post it to Happy, and then you just point ClinFHIR to that server. Yes?
So the modeler that you use in ClinFHIR, does it look like it was doing the same work as the Forge tool that I just started using?
Yes.
Is that the same?
It's not the same tool. It uses the same FHIR construct. And so the important thing to know is Forge is HL7 FHIR's profiling tool. The logical modeler in ClinFHIR is really just a sample tool for clinicians to kind of use to learn and to do some low-level, high-level maybe, profiles for them to help work with their team. Okay, thank you, everyone.
Thank you.